everyone. This is Mr. Ege, and we're using AutoCAD today. And inside AutoCAD, we're going to create a basketball hoop. And the basketball hoop, after creation, will be inserted inside the Revit gymnasium, basketball gymnasium. That is the interprofessional CAD programs project for you today. And AutoCAD is being one of the very first and most successful computer-aided design programs and most populated, most commonly used by most popular projects, the application programs of computer-aided design in the world. And wherever you go to, what parts of the world you go to, from Australia uh, to Russia, to Europe, to Africa, to Middle East, everywhere. In India, you're going to find AutoCAD, their own local language version of AutoCAD. Okay, the French people are using, and British is using AutoCAD, Germans are using, Italians are using AutoCAD around the world. So this is very commonly used program among the architects and engineers, probably the most commonly used program. So it's a standard program, and everybody relates to AutoCAD. It came around 1983. Anyway, I'm not going to talk so much about the AutoCAD. I'm just going to demonstrate how it applies, how it is used, and, uh, and to create a basketball hoop three-dimensional solid model. Okay. So one of the few things you need to know about AutoCAD is user coordinate system. When you type UCS enter, for example, computer sets the user coordinate system. Okay. Everything is supposed to show up. Everything is supposed to show up on the command menu at the bottom. Okay. Here, and this is your command menu. If you type UCS enter, okay, computer will set its user coordinate system. Why is it so important? We're setting the world coordinate system. Okay. Why is it so important? Because it determines where the XY plane is, where the Z axis also indicating. Z indicates the height of the person. Okay. X, when you extend your right hand to the right, okay, this is the X direction. When you extend your left hand to the front, that is your Y direction. So the Z is your height. Your right hand indicating the right side is your Y direction, X direction, and the left hand, okay, pointing out in front of you, literally is your Y direction. Okay, all right. So that's why it's important you have the user coordinate system set up properly. And common position is I'm right now aligning myself. Okay, I'm using the view, aligning my XYZ coordinates in such a way, and I'm pressing my thumb wheel to move uh, my screen. Okay, when you press the thumb wheel, it pans left and right, up and down your screen. You have a good control. When your thumb wheel, when you roll it front, thumb wheel, you could get closer and closer. When you roll back, it's a zoom out, zoom in, zoom out, front, zoom in, back, and zoom out. And press the thumb wheel, you have a control. So these are your first controls, virtual controls, okay? And another thing very important to know about AutoCAD is units. As soon as you log on, start a new drawing, you set your units. I type units by typing units, okay? And it's engineering, it's precision, and so on. But most people don't want to type, they don't want to type, and so on. Then what do you do? Where do you find drawing utilities? Do you have units here? Yes, you do have. So where do you go to? Drawing utilities are on the upper left-hand corner. There's a red A icon. When you click on it, it gives you a full menu. And then when you go to drawing utilities, okay, and all the save everything is in there. Units and engineering units with the 4 decimal points. 4 decimal places after decimal point. Okay, you set it to, and we're talking about inches here. All right, so everything is going to be inch. Okay. Second thing is limits. Again, you type limits. It's very important. Enter, and you set your limits. Limits is visualize how far, how much space you're going to take. This is a basketball hoop, a lot smaller than 10 feet by 10 feet. So I'm setting my limits to 10 feet by 10 feet by 10 feet. Okay, or maybe a little bit more. Let's make it 20 feet. All right. So up lower left hand corner is 0, 0, 0. Enter, and upper corner 0, 0. Enter, and upper corner is going to be 20 feet. Feet is single quote, comma 20 feet, comma 20 feet. Okay, and enter. "20 feet by 20 feet, enter." And after doing that, check it out if it agrees with that. Okay. And another thing you want to do, save as. Go to red egg icon on the upper left hand corner. Go to save as. Find your OneDrive. Okay, and save. And all right. Every time after you're saving in the right place in the first time around, every time Control S, when you type Control S, it will save it in the right place. Okay. Units are set. Units are set. Also, I want you to pay attention to my precision tools. My precision tools at the lower left-hand corner. Okay, and you have to have Object Snap blue. If it's not, click on it, please. Grid has to be blue. Okay, Object Snap is off, so it's a gray. The grid has to be blue, which is pressed. There is something called dynamic input on. It should be on, blue. Occasionally, you're going to need perfect ortho mode, perfectly vertical lines to surfaces or the XY plane. So you need to turn the ortho on when you need it. Right now, it is off. So please don't use it now. There's object snap tracking. That's very, very good quality of the object of your cursor to enable you to see and mark you with endpoints of the other lines nearby or intersection points of the other lines nearby. It shows you when you click on it and make it blue, but right now I don't need it, so I'm turning it off. And you have Snap's cursor on. Snap cursor is blue because if you press the little triangle arrow next to it, it shows you, I want the computer to show me endpoints of the lines, midpoints or center points of the lines, intersection of the two lines, and nearest points of any line, all of this, okay? So I marked them, I checked them, they're all checked, okay? And there is snap user coordinate active solid plane, so computer feels the solid plane and snaps onto the surface of the plane, even though you don't see it, okay? So that is also blue. Okay, we're good. So what do we do here? We want to create a circle, okay, with the 10-inch diameter circle. All right, so I'm going to just simply go to circle command, find many circles, center radius, no center diameter, okay, and computer is expecting me to snap onto any point as the center point, okay. I'm typing 0, 0, enter, okay. Now computer is expecting to enter the dimension. That is only 10, so I'm typing 10. 10 means to the computer 10 inches, all right, and zoom in, you can see it now. Okay, now I need to draw a vertical line to this plane in the Z direction, okay. But one of the interesting thing is, for my practicality point of view, computer is more comfortable generating on XY planes. So I want to change the XY plane so that I can comfortably design, uh, draw my lines, okay, according on the XY plane. Right now, I don't. I want my uh, path line, polyline, to be perpendicular to the circle. That is Z direction. So I'm going to change, okay, rotate my UCS around the x-axis. To do that, I'm typing UCS, enter, X, enter, and press enter again to accept the 90-degree default. Now I have a perfect XY plane perpendicular to my direction, and now I can go to polyline. I could generate. Okay, starting point. Okay. Now I'm drawing a line that 126 inches tall polyline. So I'm typing at 0, comma 126. Okay, enter. All right. All right, this is 100, exact 100. Now I want this line to be an arc. Okay. So arc is here. Okay. And it generated arc in the direction I wanted to go. But I want this to be perfectly quarter of a circle. So I calculated that the radius of the arc, okay, which is 36 inches, okay, should be entered. So here's what I'm doing. I'm typing at, okay, that is shift 2, 36, comma, 36, enter. Okay, arc is created, and I'm happy with the arc. And I think we're ready for the extrusion. Okay. So now knowing that extrusions happen on the Z direction, I want to set back my UCS. Computer remembers your previous UCS. So all I'm typing is UCS, enter, P, enter for previous. Now Z is back. Now I need extrusion. So click on extrusion, extrude. I'm selecting my circle, enter. Computer gives me options. One of them is path option, and I'm selecting the path line. Click, ta-da, and I have a perfect path line. Now to see what you have accomplished, I'm going to change my shade mode. Shade mode, okay? And all those options, realistic, conceptual, I'm choosing conceptual, all right? So this is what we created, okay? Zoom, enter, E, enter, extends. If you lose something, just enter ZE, zoom, enter, E, enter. Okay. You can save your work now, Control S. Okay. Next thing is we want to create a, based on this surface, we want to create the panel, wooden panel. Okay, that's going to support the hoop, actual hoop. Okay. All right. And to do this, I'm going to type UCS, enter. Okay, it gives me option of selecting a face, and I'm choosing my space here and accepting this. Okay, and why did I do that? Because I'm operating on the XY plane of the existing surface. Okay, and I'm changing my also direction so that I can see better, and I can zoom in here. Okay, and I'm going to draw a rectangle, any rectangle. No, it's not any rectangle. A rectangle. I'm going to draw a rectangle that is 72 inches long, 42 inches. So I'm picking any point, regardless. And I'm typing 42 because it's highlighted height. So that's 42. And place the tab key, 72, and enter key. So that's a perfect rectangle. Okay. Because I'm going to extrude this rectangle a little bit, a few inches. So that's perfectly centered. Now I want I want to center it around that surface I picked earlier. So to be able to do that, I need to know where the center of the center of the rectangle is. There are several ways of doing that. Okay. Um, for example, if I can use the move command and select the object, the rectangle, then find out the center point, the triangle shows me, and then find out the other center point, and then and the computer is supposed to show me this center point. Dynamic UCSO, but it didn't. So intersection of the two center points supposed to show me, but it's not showing me that. So that means, am I in trouble? Perhaps. Object snap tracking. I turn the object snap tracking and try it again one more time. So center point, it shows me center point. Move your cursor, now it shows me. Center point is showing me how far my cursor is from the center point, dashed lines, dotted lines. I don't know if you can see it in the screen or not. And then I'm going finding the vertical line and center point. I'm going my cursor. Now computer shows intersection of two center points. Click. Now I can move on because that's where I put the circle. Now I'm going to go right at the center of exact center of the circle. Okay, that is accomplished. If you have difficulty with this, please call me. I will help you instantly. All right, and now this is one accomplishment. Control S for save. Okay. Okay. Next, extrusion. I want this rectangle support. I'm going to use orbit command on the right hand side, and so that I can see the thickness. Okay, and right mouse button exit from the orbit. Orbit is a better controlled screen menu. It rotates everything at the small degrees of angle, and it's far better in AutoCAD. Okay, then I'm going to use the extrude command. I'm going to select the rectangle from the edge, enter. Extrusion will be for forward, so I'm just moving my cursor so it's forward. All I want is 4 inches of, so type 4, enter. Ta-da! And extrusion is created. Save your work. Control S. Okay. All right. So far so good. And next question is, we have to move our UCS to front surface of this panel so that we can generate the hoop itself. Okay. So I'm going to type UCS again so that XY plane, and I'm going to type face, click on the face, and I'm going to move my cursor on the face of the newly generated panel. Click and accept. Okay, so XY plane is perfectly there. Next thing to do is throw a circle because the hoop's supposed to be attached to a circle. All right. So I'm going to create the circle command. Okay. And perhaps find the center point. Triangle shows me the center point. Click. Now I'm generating. The computer is asking me diameter. Let's see if 1 inch, we can get away with 1 inch. Yes, it worked. 1 inch diameter. This is little bit too close. Let's move this. Okay, last item. Enter. A little bit up high. For that, I'm use the ortho mode. Click on the ortho mode on the lower right hand corner, and then move it up a little bit higher so that I can extrude it 2-3 inches or so. Okay. Okay. Um, Next command is extrude again. Sorry, extrude. Select the object. Last item, enter. And extrusion will be about, say, how much? Let's make it 8 inches. Okay. Oh, it's too much. All right, Control Z. I'm going to take it back. 8 is too much. I'm going to do 4 inches. Okay. So extrude. And last item. Click on the extrusion command. Last item to extrude. Enter. And let's make it 4. Enter. Okay. All right. Control S for save. Every time you accomplish something, always Control S for save. This is a habit I developed. They're coming from the years short, random access memory, short, small random access memory years, and for decades we struggled. All of those computer-aided design drafting personnel, architects, and engineers. We all struggled for the short RAM crashes, and we suffered the shock. So we developed a habit of every time something is accomplished, it has to be saved, because otherwise you can lose it. When something crashes. So nowadays, things still crash, computers still crash, programs still crash, but they don't as often as they used to. But habit continues, and it's a good habit. All right. So what do we need to do? We need to generate a new user coordinate system based on this plane and at the tip, very tip. Okay, so type UCS, enter, okay, and face option, select the face of the extension, click, and accept it. Cool. However, okay, what we want to create is basketball hoop surface. Okay, the surface XY plane has to be rotated alongside the Y, alongside the X. So we want to rotate so that XY plane is flat, parallel to the ground. Okay, so if you type UCS again, and this time you want to select the X action, X action, click on it, okay, and minus 90 degrees for clockwise rotation, enter. Okay, this is good. So that means we can draw our circle. Okay, and circle command. What is the size of circles? That's 18 inches diameter. So we're going to circle command, selecting the diameter, center diameter, okay? And we need to pick a point 18 inches away from the center of here. And see if I can use the from command here now. Enter. It says center point. Okay. Now the offset is, okay, shift 2, that is 80. Okay. And 0, comma, minus 18. Minus 18. Enter. Okay. And specify the radius or the diameter. Enter the diameter is 18 inches. 18. Enter. Did we create it? It created so too small. It's way too small. Let me see if I can click on it and ask the computer what the diameter of this is. Okay. So list command will give you information. List, list, enter. And it says certain radius is 18 inches. Perfect. Um, no, we want the diameter is 18 inches. Yeah. So we want to change that. Hmm. Okay, so how do we change it? Go from here. Half of the 18 is 9 inches. 9, enter. Now you want to move this circle from the quadrant point. Let's pick the quadrant point. And quadrant point will be picked based on click on the quadrant point, okay? And move your cursor, pick the quadrant point, click, and then move your cursor over the center of the circle, click. I think it's done. Now, diameter, okay. And Control S for save. And list command just to double check. This 8 inches diameter or 9 inches. Enter. Radius is 9 inches and diameter is twice as much, 18 inches. So we're good. Okay, good. Now we need to have profile created. Okay, for that again, XY plane has to be rotated. Um, one rotation will not be enough. We're going to need 2 rotations. Okay, so I'm going to type UCS. Okay, X direction, enter, and then UCS Y direction, enter, enter. Okay, now my UCS XY plane is perpendicular to the circle. Good news. We can draw the circle based on this. So go to circle command and select the center point. Click. I'm going to change the angle a little bit to the sideways. Oops, control, okay, escape, Z, enter, P, enter for previous, Z, enter, P, enter. Okay. And I will use the orbit command to change the angle. Okay. And I'm going to use the circle command to generate the circle anywhere outside. Now, what are we talking about? Diameter of 1 inch. Enter. Move the circle. Click. And turn off ortho mode that I was in before. Click. Okay. Now, is the hoop ready? Almost ready. Are we going to extrude? Yes. Go extrude. What are we extruding? The profile we just generated. Enter. And what's the path? Click on the path. And select it. Okay. This is the hoop. And Control S for save. Okay. So, how are we doing so far? It's almost finished. And in AutoCAD, you can change the colors and stuff, everything. You can save it and so on. Control S for save, okay? And you can select the surfaces and then change the colors as well. For that purposes, we have solid model color surface commands. Okay, color the surface. You choose the surface, enter. It gives you a bunch of colors, and probably green or darker green is a better color. Okay, and so on. Okay, and then you can turn off the grid mark. You're done. Okay, you can add also materials too. This is totally something you can do. Okay, all right, and there are also okay the ropes sticking down from the loop, from the hoop, and that also requires some kind of a polyline. Okay, to be able to do that, we need to zoom in this area, create a line command, polyline command. Okay, we so far, if you notice, we always created a polyline. Okay, and okay, enter, and when you create a polyline, that's so not perfect. You go to poly edit and select spline up, select the polyline, and then you can spline curve it and close, open, spline curve it. Okay, okay, that gives you some ability, some option over the curve, the quality of the curve, and so on. Okay, um, so you might as well you put your UCS, user coordinate system, right at the end of the spline command. Okay, here, enter. We need to draw another, probably a circle. It will work far better. Maybe right over here, so that we can generate, okay, and a thickness. Okay. All right. I'm going to type UCS one more time to select the end. Okay, and enter, and then move a little bit like that. Okay, and exit. Now I need a circle. Okay, and I'm going to pick a circle, not too big, not too small. Okay, and hopefully I'm going to extrude this circle. So use the extrude command and select the circle, enter, select the path option, enter, select the path line. Okay, now we have one object generated. Now, um, this is all good, but literally it has to be attached to the hoop now. So how do we do that? Okay, type UCS, type Y, type UCS, enter, and Y rotation, enter. Okay, and then you want to move this object that you generated from where it is to where it should be. Move the object I'm going to attach it to here. Okay. All right. However, having done that, I want to use now change my UCS. So type UCS, enter, and the center point. As soon as you pick the center point, put it here, enter, and look from top down if I can, because I want to use the array command now. Z has to be rotated. So UCS enter, X enter, rotated, enter. So Z now vertical. Why did I set the Z? Because I'm going to use array command. That's my next. And the array commands are always require the Z being perpendicular, right? At the center of the array. Circular array. So I go to circular array on the top, in the middle left, polar array, select the polar array, and select the object that I want to array. And it's asking me the base point. And base point is center point. So I'm selecting the hoop because it shows me the base point. Click, and it it generates 6 copies. That's not enough. Go to items, make it 24. Enter. And whether it's a satisfactory or not, check it out. 24 is not even enough. Maybe we should do more. Okay. So go to items, maybe 32. Enter. I think this is more satisfactory from the way it looks right now. Okay. And save. Now it's enter. Okay. Control S for save. And thank you very much for watching this activity. I'm suggesting you to do the same and give me a call if you need help, or at least even if you don't need help, just show me if you're finished it or when you're done or when you're not done. Either way is fine. Big question. What do you do to base? How do you install a basketball hoop to the ground? And probably you don't know the answer of this because I'm an architect, so I know how to do that. Uh, I would put a thick plate underneath. Okay, I would definitely weld the thick plate to the pipe, and then the thick plate can be bolted down safely, securely. So that's what I'm going to do now. I'm going to go underneath, turn this underneath, look inside, put my UCS there, enter, and computer feels, I select the face option, computer feels that and click on it, accept, oops, Control Z, escape, type UCS, enter, okay, select the face option. Okay, now it did it, perfect. And now we're talking about drawing a rectangular plate underneath for anchoring the system, the piping. So I need a rectangle, perhaps, and slightly larger than my system is. Now, its computer shows me about, say, 1 foot. I'm going to go with 1 foot, say, 6 inches option. 1 foot 6. 1 foot 6 inches. Okay. Press the tab key. 1 foot 6 inches. Enter. Okay. And again, centering is the problem. So draw a line from one corner. Computer knows where the center is of the line is, so I don't need to draw 2 of them. I'm going to move this object from where it is. So I need to pick the center point. It shows me with center point with triangle. Now I'm going to use the center point of the circle. Click. Perfect. Okay. I'm going to erase this line. I don't need it anymore. Now I'm going to extrude this object, this square. Extrude the square in the Z direction. Okay. What can I say? It's important. Architecturally, it's very important. Engineering-wise, it's very important. I am engineer. I am an architect. It's very important for me to create this hoop together with the anchoring plate. So anchoring plate is there. And use the extrude, click, select the object, click, enter. It will go down. How far? At least 1 inch. I'm going to have at least 1 inch. Enter. We're good. Perfect. And what do we do? Well, number of things. You can union at this point. Union command. Union is really good command to join the objects to each other. Enter. Okay. I don't need to union the wooden panel part in the back, but I can change the material. Okay. So what material do you suggest? Steel, stainless steel. RMAT. RMAT is short for, it's a command, name of the command, short for rendering materials. Okay, enter. And if you can find steel here, you can apply it. Search steel. Okay, I can click to save the steel, and I can literally apply the steel here. Okay. Okay, so this project is finished pretty much, and uh, this is the final form. Okay, and the stainless steel. I use the stainless steel to change the support of the hoop, basketball hoop, and this looks like that. And I didn't add any lights or any background images or anything, but save it. I suggest you save it and then insert into the uh, your Revit gymnasium, okay, as a DWG.DWG feed. When you save this, it saves as in DWG. Make sure that you know where you save it in OneDrive, and make sure that your names are correct and everything. And then when you insert it, all the properties is going to come together, but you need to insert two of them, okay, or at least make a copy when inserted and rotated. They're going to be against it. Okay, thank you very much for your great time also, and I think you learned something very useful. If you have any difficulty, make sure you call me. I make sure that this is the kind of thing and learning that never will go away from you. You'll never ever gonna forget it because you have done it once. You remember it. You spend time with it, and this is the basic of the heart, very heart of the efficient learning. Thank you very much for your time. Have a great day. Bye.